Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about errors. A small component in an electronic device has two small holes where another tiny part is fitted. In the manufacturing process, the average distance between the two holes must be tightly controlled at 0.02 millimeters, else many units would be defective and wasted. Many times throughout the day, quality control engineers take a small sample of the components from the production line, measure the distance between the two holes, and make adjustments if needed. A significance test was run at the alpha equals 0.1 level on a sample of distances with a null hypothesis that the distance between the two holes is 0.02 millimeters, and an alternative hypothesis that it is not 0.02 millimeters. The test resulted in a p-value of 0.183. Now, I'm going to pause here for just a second. Note that our p-value is greater than our alpha, so here we would fail to reject the null hypothesis in favor of the alternative. And we're asked what error could have occurred as a result of the significance test. Well, since we failed to reject the null in favor of the alternative, it's possible that this null hypothesis here of 0.02 millimeters is false, and this would be a type 2 error. And I wanted to talk for just a second about what that means and what that would look like. So to run this test, we assumed 0.02 was the true mean, and we built a sampling distribution around that value. So here we have 0.02 millimeters as our mean, and supposedly we got some sample mean over here, x bar, and we said, well, this area to the right and then reflected over here to the left of that value has a probability of occurring of about 18%. Remember that p-value is that area. And so we say, well, that's not very rare, so we're going to fail to reject that 0.02 as the true value. However, it is possible that 0.02 is not the true value, and the true value is over here somewhere. Let's mark this. Let's call this question mark. There's some true value that is the actual mean distance between these 2 points. These two holes in this problem, and then the actual sampling distribution looks like this. And since we got an x bar that's reasonably close to this mystery true number, but is also reasonably close to that 0.02, that we failed to reject the 0.02 even though it is false. And this is a type 2 error. Thank you for joining us. I'll leave you with this quote by Leo Buscaglia. Have a great day.